how to prove that under root 2 is irrational number. Okay, so we prove it by the method of contradiction. We assume that under root 2 is a rational number. If under root 2 is rational number, that is, we can write under root 2 in the form of p upon q. The basic definition of the rational number is a number which can be written in the form of p upon q. Okay, p and q should be integers and q should not be equal to 0. This is the definition of the rational number. A number which can be written in the form of p upon q. P and q should be integers and q should not be equal to 0. We also assume here that p and q are in their simplest form. By simplest form, what we mean? P and q are here co-prime numbers. So by co-prime number, what we mean? We say two numbers are co-prime. We assume here that, and let me write it here, p and q are co-prime. Co-prime. So by co-prime, what we mean? Numbers having 1 as common factor are called co-prime. Like we have 2 and 3. 2 and 3 are co-prime because the common factors of 2 are 1 and 2, and common factor of 3 is 1 and 3. Here we can see only 1 is the common factor. So we say 2 and 3 are co-prime numbers, but 4 and 8 are not co-prime. Why? Because the factors of 4 are 1, 2 and 4, and factors of 8 are 1, 2, 4 and 8. Here we have two common factors, that is 1 and 2. We say 4 and 8 are not co-prime, but 2 and 3 are co-prime. Why? Because 2 and 3 have common factor only 1. Here 4 and 8 have two common factors, that is 1 and 2. Okay, so we assume under root 2 is rational. That means under root 2 can be written in the form of p upon q, where p and q are co-prime. They have no common factor other than 1. Okay, now what we do, we square both sides. So squaring both sides, so we have under root 2 square, and here we have p square upon q square. Okay, here square and root gets cancelled. We are left with 2 is equal to p square upon q square, or we can cross multiply them. So p square is equal to 2 times q square. Now what does this mean here? It says us that p square is a multiple of 2. Okay, so here p square, this number is a multiple of 2 because we have 2 here, 2 times q square. Okay, that means p square is multiple of 2. Now if p square is a multiple of 2, that means p square is even number. If p square is even number, that means p is even number. Why? Let me explain it here. Let us say we have 2 square. So square of 2 is equal to 4. Okay, square of an even number is also a even number. That is, 2 square is equal to 4. 2 is even, and square of even is also even. If we have 3 square, so here it is odd, but square of 3 is 9, which is odd. So this property is simple. If p square is even number, that means p in fact is an even number, obviously here. So it implies p is even number. Okay, so let us remember this. Now we plug, if p is even number, let us suppose p can be written as a multiple of 2. So let us say 2 times k. So if p is an even number, that means p can be written as a multiple of another number k. Okay, now what we do, we plug the value of p is equal to 2k in this equation. So in place of p, we have 2k square this time. Okay, so we can write 2k square is equal to 2q square. So here it is 2 into 2 is 4, rather 2 square is equal to 4, k square is equal to 2q square, dividing both sides by 2. So let us divide here 2, here 2, we get 2k square is equal to q square. Okay, Now what does this mean? So it means q square is equal to twice k square. So see here again, here we say q square is a multiple of 2. Okay, so this tells us that, or rather q square is multiple of 2. If q square is a multiple of 2, that means q square is even number. Even number, as I have explained it earlier, if we have 4 square, so 4 is even. So the square of an even number is in fact even. Here you can see we get 16. So if q square is multiple of 2, means q square is even number, implies q is also even. Q is even number. Okay, if q is even number, so can we write, or let me write it here like this. So if q is even here, and we have seen p is also even number, so here we can see we have what we got the result, that is p is even number, q is even. Okay, that means p and q are not co-prime, implies p and q are not co-prime. Why? If p is even, q is even, p and q are not co-prime. Let us take any two numbers. Let us say we have 4 and 6. You can see they are not co-prime. So we have 1, 2 and 4. Here 1, 2, 3, 6. So we have two common factors. If p is even, q is even, like we have 4 is even, 6 is even, p and q are not co-prime. So this violates our co-prime property. So co-prime property gets violated, that we have assumed p and q are co-prime, that is under root 2 is in its simplest form, because we are not getting p and q in its simplest form. That means this assumption is violated. That means our initial assumption that under root 2 is rational is incorrect. If it is incorrect, if under root 2 is not rational number, that means under root 2 is an irrational number. Okay, so let me repeat it here again, or explain it here. We are saying that we got this result, p is even number. So if p is even, q is even number, obviously, that means p and q have common factor 2. So p, q have common factor as 2, but we have assumed p and q are co-prime. That is, we have assumed p and q have only 1 as a common factor, 1 as common factor, but we are getting common factor as 2. That means p and q are not co-prime. That means our co-prime property gets violated. That means our initial assumption that under root 2 is rational is not correct, implies under root 2 is an irrational number. I hope I have done justice with this question. If you want to find out more videos on mathematical economics, so this channel is dedicated to mathematical economics. Occasionally I take pure mathematical questions here. Okay, so keep share this channel with your friends, give your feedback. That is the only motivation for me to make more useful stuff for you people. Keep shining and stay blessed.